In this Algebra video, we're in Chapter 10, Lesson 3. We're going to talk about doing mathematical operations with radical expressions. Our objective is, as the student, I can add, subtract, and multiply radical expressions because I will simplify everything and look for like terms. Mostly what I just said for looking for like terms for adding and subtracting. Notice, I did not say dividing radical expressions because we already talked about what to do with quotients in the last video. So when we talked about simplifying, check that video for dividing. It's just a matter of simplifying top and bottom and rationalizing the denominator, all that stuff from the last video with dividing. Alright, some things to keep in mind, or some truths to live by. All operations with radicals are just like operations with monomials. I mean that seriously. Literally, for most questions, if you just pretend that the radical, whatever it is a variable. So I'm just going to make up this question real fast, real sloppy. If you have 3 square roots of 4 plus 5 square roots of 4, pretend that's 3x plus 5x. That's what I literally mean. The rules you would use for that are the same rules you'll use for the radicals. So a lot of these questions you can help yourself if you pretend. Use what you already know about monomials. You need like terms with radicals. You need like terms in order to add and subtract, just like you would with monomials, just like you would with fractions, just like you would with lots of things. And if you need a factor, or you want to use the distributive property or the FOIL technique or any of those, you can factor the same way you normally would with monomials. When I say the same way, I mean the same way you would with monomials. So everything we talked about a couple chapters ago in Chapter 8 with multiplying, special products, or factoring, any of that stuff, it all can also happen with radicals. Let's get into some examples. Let's start with some basic ones. Go ahead and jot these down and follow along with me. We have 2 times the square root of 5 plus 4 times the square root of 5. I already mentioned you need like terms when adding and subtracting. Well, the good news is we have like terms. It's the square root of 5. So pretend this question was just like a monomial question. Think of it as 2x plus 4x. And you know that the answer 2x plus 4x is just add the coefficients. 2 plus 4 is 6, so 6x. That same concept is what we're going to use for this one. We're going to pretend that this was like the variable. So we're going to add, think of these as coefficients. I may have hinted to that in the last video when I used to put a 1 in front of them if there was nothing. Same thing happens here. So 2 square root of 5 plus 4 square root of 5 is 6 times the square root of 5. So this was a basic example. That is your answer. That is a fully simplified answer to this question. Now, if you're ever wondering, like some of you might be thinking, well, how do I know I did this correctly? Go back to already what I talked about last video. Go ahead and check the decimal value. I know you're going to have to round, but at least get it close. Do the square root of 5, and then do the square root of 5, and then times it by 2. Do the square root of 5, and then times it by 4. Then add both those together. You're going to get the same number as if you had just done the square root of 5, and then hit times 6. You can get the exact same decimal. I will hit pause when I did that off screen, and it actually checks out. The left side equals 13.416, the right side equals 13.416. Mind you, I'm rounding, but still, that's what I'm saying. That's how you can check yourself to make sure you do any of these questions. Now, I'm not going to take the time to do it for all these examples, but it can be done for all of them. Just take your time, and you can always check yourself by checking the decimals. The whole point is, though, we're trying to avoid decimals, but it helps you check yourself. Let's go on to the next example. Take a look at the example at the bottom. Now, treat it as if you need coefficients. So, for example, if you don't have a coefficient out there, it's the number 1. So think of this. So you can think of this question just as 1x minus 4x. Notice our first 2 examples already have like terms. Well, 1x minus 4x is negative 3x. Well, that same concept is what we're going to use. 1 minus 4 is negative 3. So just keep the like term, square root of 6. So your answer is negative 3 times the square root of 6. That is the fully simplified answer. And if you're not sure if it's fully simplified, check the factorization of 6. You'll notice you'll have no doubles. Now, when you add and subtract, just to put this, won't say this before we move on. When you add and subtract, you need to leave the like term alone. You don't need to mess with it when you add and subtract once you have a like term. You don't affect it. Kind of like when you add and subtract, you don't mess with denominators, with fractions. You keep it. This is the same similar thing. Once you have that like term, when you add and subtract, you keep it. It is going to get affected, though, when you multiply and divide. Alright, so let's take a look at this example. We're going to be, in this case, adding, and we have unlike terms to begin with. So the first thing I'm going to tell you is, for all these questions, especially adding and subtracting, Start by simplifying all your radicals fully, using the skills we talked about in the last video. So if you think you already have a handle on that, take a moment and see if you can simplify square root of 27 and square root of 48 and square root of 12 if they can simplify, and then we'll fill those in their spaces. So try to simplify square root of 27 yourself first. Okay, technically the trick I've been teaching you is factoring it fully and looking for repeats. But I also said technically you're looking for perfect squares in your factors. For example, 27 is 9 times 3. Well, 3 doesn't go any further, but 9 does. But 9 is also a perfect square. We know the square root of 9. The square root of 9 is 3. So we're going to have a 3 on the outside. But if that doesn't quite work for you, stick with my little rule how I said look for repeats. So I'm just going to go further and go all the way that far. So you notice 3 has a friend to go outside and play with. So 3 gets to go outside the house and play. Whereas that other 3 does not have a friend. He stays on the inside. So square root of 27 simplifies the 3 times square root of 3. So I'm just going to fill that in its spot. 3 times square root of 3. Now let's simplify square root of 48. Try it yourself first though. Try it yourself. See if you can simplify square root of 48. Well, when I think of square root of 48, I'm thinking 12 and 4. When I think of 12, I think of 2 and 6. When I think of 6, I think of 3 and 2. When I think of 4, I think of 2 and 2. Now be careful. When I did it this way, it might be easy for you to lose track of where things were, but the bottom row would be these numbers. Those numbers I just put in that U shape, that's your bottom row. So those are the ones you're checking for repeats. So sometimes be careful how organized or unorganized you may be. Alright, so I see a double of 2's here. I see a double of 2's here. And this 3 has no friend to go outside and play with. So we're going to have one 2 on the outside. We're going to have another 2 on the outside. And then we're going to have a 3 stuck on the inside. Well, 2 times 2 is 4. So that's 4 times the square root of 3. So now you simplified that one fully. Alright, so fill that one in its spot underneath square root of 48. Now let's go ahead and simplify square root of 12 fully if we can. Or it may already be simplified. Let's go find out. If you haven't done so already, hit pause and try to simplify this one yourself. When I think of a perfect square that goes into 12, I know that 4 goes into 12 3 times. And I know the square root of 4. I know the square root of 4 is 2. So I know that I'm going to have a 2 on the outside and a 3 on the inside. But to stick with the rule, the pattern, the trick I've been showing you, I'll go all the way. 4 is 2 times 2. Well, we have a double of 2's, so we have a 2 on the outside. 3 does not have a friend to play with, so 3 is stuck on the inside. So 2 times square root of 3. I was just trying to explain 2 different ways to simplify, ways of thinking of it. Okay, you have everything ready, and you'll notice, look at this, everything is a like term. So you can go ahead and add all of these together. Add your coefficients. 3 plus 4 is 7, 7 plus 2 is 9, and 9 times square root of 3. 3 was your like term. That is the fully simplified answer to this question. And you're good to go, you're done. Feel free to check it by checking the decimals, square root of 3, hit times 9, and then do it for all of these and add them together. You'll notice you'll have the exact same decimal value. Let's do another example. In this case, we'll be adding and subtracting, and we're going to have unlike terms. Now, actually, before I get to the example, I meant to say, a quick what-if scenario, I apologize, I should have said this already, was if you happen to not have like terms in one of these, let's say you had a 5 underneath that one. If that were the case, you only would have added your like terms to the ones you had, so you would have had 7 square roots of 3, and because in this example, 2 square roots of 5 wouldn't have any like terms, you would just have written it separately, and that would have been your answer. It's okay if you have 2 terms as your answer, as long as they're not like terms. That is allowed. So I just wanted to mention that what if. Hint, hint, that's going to happen in our next example. So if you think you already feel confident simplifying some of these radicals, if they simplify, go for it. But I already give you a hint that this one doesn't simplify. 2 doesn't go any further. And 6 also will not simplify. But you may want to check to see if the other 2 simplify. So we're going to do that now. Alright, when I think of 50, I think of 25 times 2. Some of you may have thought of 10 times 5. Some of you may have thought of something else I'm not thinking of. It doesn't matter. Alright, well, 25 is 5 times 5. Okay, we've got our prime factorization. We have our doubles of 5, so we have one 5 on the outside. 2 has no friend, so 2 is stuck on the inside. So 5 times the square root of 2. So when you put that in its place, notice you got to put that minus sign in front of it. So that's going to be minus. Now I'm going to drop those other ones down in the front since they don't simplify. So now I'm going to check to see the square root of 24 simplifies. Try it yourself first though. When I think of 24, I think of 4 and 6. When I think of 4, well, that's a perfect square, so the square root of that is 2, but that explains why we have a double of 2's. When I think of 6, I think of 3 and 2. Alright, so we have a double of 2's. So we're going to have 1 2 on the outside. We have a 3 and a 2 that have no friends to play with, so they're going to be stuck on the inside. So we're going to have a 3 times 2 on the inside. Well, 3 times 2 is 6. So we have 2 times the square root of 6. So I'll put that in its spot. Alright, so plus 2 times the square root of 6. Alright, so we've simplified all of our radicals fully. Now we're ready to look for like terms and get those added together. I see that we have 2 square roots of 6 happening here. You have 3 square roots of 6, and you have positive or plus 2 square roots of 6. Well, 3 plus 2 is 5, so we have 5 square roots of 6. Now do the same thing for your square roots of 2. Notice that's a minus sign in front. You have to abide by it. 3 minus 5 is negative 2, so you have negative 2 times the square root of 2. And now we are simplified fully. This is the answer to our question. Alright, so basically that's it for adding and subtracting. So now let's talk about multiplying. When multiplying with radicals, just know all of this stuff, it uses the distributive property or the FOIL technique or the double distributive, whatever you want to call it. The good news is you do not need like terms to multiply radicals. So let's start with a basic example. In this basic example, you just got to get rid of the parentheses. Well, to get rid of these parentheses, you already know that's called the distributive property. So go ahead and multiply both of these out. So you'll have 2 times the square root of 3. Well, that's just 2 square roots of 3, touching them together. 2 times 4 times the square root of 5. Well, 2 times 4 is 8, and it's a positive times a positive, so it's plus. So it's 8 square roots of 5. Now, you could go ahead and check to see if these were like terms, and you could combine them, but if they were like terms, most likely these would have been, so we would have combined them first. But either way, this is your answer. 2 square roots of 3 plus 8 square roots of 5. That is your final answer to this question. That was a basic one, using the distributive property. Feel free to try this example yourself. I want to do an example where the thing on the outside wasn't just a regular number, where it was an actual radical, so you'll have to review how to do a radical times a radical. But if you think you remember how to do this already from the last video, once you apply the distributive property, go ahead, try this one yourself first. Alright, so first we're going to have square root of 6 times square root of 3. Okay, so square root of 6 times square root of 3. Now, the product property tells us we can separate things when they're underneath a radical. Well, the opposite is true. You can also put them together. If they're separate, you can put them together 6 times 3. Well, and 6 times 3 is 18. So the first one equals square root of 18. Now, let's go ahead and multiply the second one. Square root of 6 times all of that. Now, notice, this is like its coefficient, and its coefficient out here is like a 1. So you're going to have a negative 2 in front. So minus 2, but now deal with the inside. Now you'll have square root of 6 times square root of 6. Well, that's the same thing as think of it as square root of 36, because 6 times 6 is 36. I guess I could show my step like I did the one next to it. And then that tells you negative 2, 36. And now you're good. You think you're done, and you've done a great job if you got this far on your own, but you have to remember, let's check to make sure that either of these are simplified fully or can be simplified further. Because if they can be simplified further, there's a chance we might be able to combine them now using the skills we just talked about with adding and subtracting. But regardless, we want to simplify fully either way. So let's just go ahead and simplify both of these. Let's start with the square root of 18. Square root of 18, I think of 3 and 6. Or maybe you're someone who thinks of 9 and 2 because 9 is a perfect square. That would have been a better choice. Well, square root of 9 is 3, or think of it as 2 doubles of 3. Okay, so we have a doubles of 3, so 1 3 on the outside. That 2 does not have a friend, so he stays on the inside. So square root of 18 is 3 times the square roots of 2. So I scoot everything up and I made the left side as 3 square roots of 2. Now let's see if this right side simplifies further. Okay, so we'll deal with that 2. That 2 will be on the outside for our answer. We'll multiply when we're done, but let's start by simplifying this. When I think of 36, I think of 9 and 4, which is good because 9 is a perfect square. We know the square root of 9, it's 3. Or factor fully, and you notice you have a double of 3's. So you have a 3 on the outside. This 4 has no friend, so you have a 4 on the inside. And note it, don't forget, you still have that negative 2 out front. So that negative 2 is still out front, but they're multiplying together. Whenever you have things both on the inside or both on the outside, it's multiplying. Well, 3 times negative 2, well, that's negative 6. So you saw that square root of 4 on the inside. So negative 6 times the square root of 4. Oh, but wait, I could have factored further, I just realized. Notice, we know 4 isn't all the way, because 4 is a perfect square. It's 2. So let's adjust this slightly. So we put our doubles of 2 on the outside, perfect. And then we bring down that negative 2. Okay, we're ready to go. Oh, and some of you might be thinking, well, duh, you goofball. We know the square root of 36. It's a perfect square. It's 6. And 3 times 2 is 6. So it actually, we already knew that, but that's okay. All right, so 3 times 2 is 6. 6 times negative 2 is negative 12. All right, so the right side equals negative 12. Okay, so you've got both terms of this binomial simplified fully. So look to see if they're like terms if you can combine them, and they're not, because this has a radical of 2 and this has, technically it has a radical of 1 if you wanted to, but they're not like terms. Alright guys, so this answer is simplified all the way. Alright, so take a look at this example. This example is going to be a binomial times a binomial, so you're going to be using what we call the FOIL technique, or double distributive property. But take your time, show your work, and if you think you can understand each of these, give it a shot. But I'm going to go ahead and point out, even if this had been like a regular 8 and not a square root, it would still be the same setup. You would still do the FOIL technique like that. So keep that in mind. So go ahead and let's be neat, let's be careful and show our work, and let's see what we get. Alright, so square root of 8 times square root of 5, well that's square root of 40. We'll look into seeing if that simplifies later, but for now we're just going to do the multiplying step. Now I'll go and do the other one. Square root of 8 times square root of 3. And that's going to be the square root of 24. Alright, now don't forget the other one. Don't forget doing that other combination. Square root of 2 times square root of 5, well that's square root of 10. And then square root of 2 times square root of 3, that's square root of 6. And you'll notice now it's just like a regular adding problem we just talked about. Square root of 6 and square root of 10 don't simplify further, and you could check, but this is just 3 and 2, no doubles. This is 5 and 2, no doubles, so they don't simplify any further, but the other two do. So take a moment to simplify those further, and now choosing a skill we already talked about. Then we'll combine like terms. Square root of 40. Go ahead and do this yourself if you think you already can. When I think of 40, I think of 4 and 10. Well, 4 is 2 and 2. 10 is 5 and 2. Okay, so we have a double of 2's, but we do not have a double of 5 and 2, so they stay on the inside. 5 times 2 is 10, so on the inside we have square root of 10. So 2 times the square root of 10. Alright, move on to the next one, square root of 24. Let's simplify that one. Okay, square root of 24. A perfect square that goes into that is 4. 4 goes into it 6 times. And honestly, it doesn't matter if you choose 12 and 2. Remember that, we talked about that in the last video. 4 is 2 and 2. 6 is 3 and 2. Okay, we have a double of 2's again, so we have a 2 on the outside, but we do not have a double of 3 and 2, and 3 times 2 is 6. So we have a 6 on the inside, so 2 square roots of 6. And I already mentioned those last two don't simplify, so I'm just going to drop those down. Okay, now just combine like terms. If you need to, pretend there's a coefficient in front of these, so you can remember that there's a 1 in front, so keep that in mind. Alright, so we have 2 square roots of 10, so one of them is a coefficient of 2, the other one has a coefficient of 1. 2 plus 1 is 3, so we have 3 square roots of 10. Then take care of your square roots of 6. So 2 plus 1 is 3, so 3 square root of 6. Now, it's a coincidence both these happen to be a 3, but that's basically, it's no big deal. Alright, so that's our final fully simplified answer. 3 square roots of 10 plus 3 square roots of 6. And again, if you ever have your doubts, check the decimals of this and check the decimal version of this. You'll notice it'll be the exact same decimal. Alright guys, so this was an example of the FOIL technique. I'm now going to give you a couple you-try examples for you to do, basically the type of stuff we've done, and I might make you stretch it a little bit. Try them on a piece of scratch paper if you're not sure if you're doing them correctly, but then check yourself with the video. I'm not going to quite over-explain them as much as I did as these, but I will make sure that you get an explanation for them. Actually, I think for the time's sake of the video, I may just give you a little bit of a tougher one for you to try on your own. It's going to use all these skills in one. We're going to be doing some adding, there's going to be a little bit of multiplying, a little bit of everything. So it's going to allow you to use all your skills in one. I know what you're thinking. An example of fractions. But you'll be okay. We'll take our time, we'll go step by step. But go ahead and see what pieces of it you think you can do on your own, and don't freak out like Bart and Lisa. Start by using the quotient property. Give the 2 its own square root. Give the 3 its own square root. Okay? Now, we could actually focus on the left one first, or And I'm going to go ahead. Let's go ahead and focus on the left one first. Let's use what we learned in the last video. Let's start by rationalizing this denominator. Let's get that square root of 3 out of the bottom. And as a reminder, when rationalizing the denominator, to get that out of there, you multiply by what the radical is. And it's square root of 3 in this case. Alright, so up top we get square root of 6. On bottom, square root of 3 times square root of 3, well that's just 3. Technically it's square root of 9, but the square root of 9 is 3. Alright, so square root of 6 over 3, that's what that left one becomes. Okay, now let's go ahead and take care of using the quotient property to simplify the one on the right side as well. So let's go ahead and simplify this one. The first thing I'm going to say is I'm going to say give the top and bottom of that fraction its own square root. So minus 4, that stays there. Give the 1 its own square root. Give the 12 its own square root. Now, take care of rationalizing this denominator. Let's go ahead and simplify the bottom of this one first, though. Before we rationalize the denominator, let's go ahead and simplify square root of 12. Well, the square root of 12 is 4 and 3, and 4 is a double of 2. So that means 1 2 on the outside and a 3 on the inside. So that's what the bottom of that one becomes. Okay, so then when we go to rationalize our denominator, we only need to multiply top and bottom by square root of 3, only by the actual radical you're trying to get rid of. Alright, so on the top, square root of 1 times square root of 3, that's just square root of 3. On the bottom, square root of 3 times square root of 3, that's 3, okay? But this is 3, so we have 2 times 3, so that's 6. So we're going to have 6 on the bottom. Now, honestly, it didn't matter if you didn't simplify this first. You could have started by multiplying top and bottom by square root of 12. But you would have noticed what you would have ended up having. You would have ended up having to simplify. You would have had something like 2 over 12. And that would have simplified to 1 over 6, which is the same thing we have. So again, it doesn't matter if you simplified it or not before you rationalize the denominator. It just makes it neater if you do. Alright, so that's square root of 3 over 6. But technically, remember there's that negative 4 in front. So we have negative 4 times square root of 3 over 6. Well, if we multiply these together, you can think of that as negative 4 over 1. When you multiply top times top, bottom times bottom, well, if we do that, we'll have negative 4 times the square root of 3 over 1 times 6 is just 6. So you have that, but you actually can simplify these two numbers. 2 goes into both those numbers. So if you do that, you'll have negative 2 times square root of 3 over 3, because 2 goes into 4 2 times, 2 goes into 6 3 times. That's how we got these numbers. So now that's our right term. Now that's good news, because I'm starting to notice when you add and subtract fractions, you need common denominators. Well, take a look, we have common denominators, so we're going to be able to hopefully work with that. But what about this middle term? This middle term right now is over 1. Well, if we wanted to have a common denominator of 3, we've got to use our common denominator skills. So think of it this way. It's currently over 1, but we want it to be over 3. And do what you did way back when, or actually what you learned in middle school, or when you do common denominators. We want it to be a 3, so we multiply top and bottom by 3 in order to give it a denominator of 3. And if we do that, 3 times 3, that's actually who you multiply it by up top. 3 times 3, well that's 9. So you're going to have 9 times the square root of 3. And on bottom, 1 times 3, well that's just 3. Now, I hear you that this simplifies, but it would give you right back to this. The whole point is we wanted to do this so that we would have the like denominators on the bottom. So let me go ahead and drop that one down. Okay, so I dropped that one down, and look what we have. We have common denominators on the bottom. And when you have common denominators on the bottom, you just do it to the top and you keep the bottom. Okay, so when you add and subtract the top, you're going to use the skills we talked about when it's adding and subtracting. You need like terms. Well, square root of 6 has no like terms on the rest of the top. So when you go to write your answer, square root of 6 is going to be by itself. These two do have like terms. It's the square root of 3. So that like term is going to go through as square root of 3. Now subtract the coefficients. 9 minus 2 is 7. Notice it's positive 9 minus 2, so it's positive 7, so a plus sign. The common denominator is a 3, so you keep it on the bottom. We are finally done. I hear you. This question had lots of stuff for us to do. There are a lot of things to keep track of. We used a lot of background skills on this, but it was a good, challenging question, and this is our complete final answer. So well done if you stuck with me through here, and fantastic and impressive. You got most of the way through this question on your own. Alright, so we've taken it all together, we've added, we've subtracted, we've got like terms when we added, we did not need like terms when we multiplied, but when we multiplied, we used the distributive property, we used the foiling technique when multiplying binomials, we simplify when we can, we do everything we can to make the questions as simple as possible, because I think you'll admit, even though it may have been kind of tough getting here, this answer is a whole lot more simple than what we started with. Alright guys, take care, I'll see you in class.